Today we're going to be talking a little bit more about higher derivatives, an extension of what we did the other day. The other day we found them by deriving again and again, but we also looked at their graphs and talked about what the pictures look like or what the graphs look like of a first derivative and a second derivative. So today we're going to do a little more with the algebra side of it. A ball thrown in the air at a height of s of t equals 80t minus 16t squared. Find the velocity and acceleration at time t. So the velocity is the first derivative. So we get 80 minus 32t, and that would be meters per second. Acceleration is the second derivative, which would be negative 32 meters per second squared. Now, when is the ball speeding up? If you remember from a previous lesson, a ball is speeding up when the velocity and the acceleration have the same sign. So, let's check this out. We're going to have to make a number line checking out velocity and acceleration. Well, let's talk about velocity first. Velocity is 80 minus 32t. We need to find out when it equals 0 so we can decide when it is positive or negative. If you solve that, you get 2.5. So, if we plug in a 1 into our 80 minus 32t, we're going to get a positive number. If we plug in a 3 into 80 minus 32t, we're going to get a negative number. Acceleration is negative 32. You can't plug anything in, but we know negative 32 is negative all the time. So it's going to be negative here and negative here. Where are those the same? Well, in this section, which means the ball is going to be speeding up when t is greater than 2.5 seconds, or from 2.5 to infinity. A little bit of a new notation for you, and something you are definitely going to want to remember. I know for sure it showed up in the 2015 AP test. But it's not hard, it's just the notation for a second derivative. If you can't recognize it, then you don't know that you need to derive again. So, the first two are kind of common sense. You know those are the second derivative, that's easy. But this third one is one you'll see a lot, and you need to be able to recognize that that is a second derivative. Please do not forget this. Write it like that once in a while when you're finding second derivatives, and it'll help to seal it in your memory. This last one, d squared f of x, really rare, you won't see it too much. Now, y cubed works the same way. It has not y cubed, the third derivative works the same way. 3 primes, similarly. But when you get to the fourth, they no longer use apostrophes to mean derivatives. Instead, they put a number in parentheses, and they put it in parentheses to show you that it's not an exponent. So that is something you should be familiar with. Now, occasionally, we have to find second derivatives implicitly. To do that, we have to implicitly find the first derivative. And we find out when we solve for dy dx that negative 4x cubed divided by 4y squared, or negative x cubed over y cubed. Sorry, that's not squared. Cubed is the first derivative. Now to go on, we need to find the second derivative. Now the second derivative, d squared y over dx squared, is going to need the quotient rule. So we get low d high minus high d low draw the line, square the low, and from here, we're going to need to simplify a little bit. We've already have it solved for the second derivative, but we have this first derivative over here causing a problem. So, to get rid of that, we're going to plug in what the first derivative equals, and now we have something we can work with algebraically. So, we end up with 3x x cubed y squared, I'm getting ahead of myself, times negative x cubed over y cubed, all divided by y to the 6th. Now, from here, we can simplify a little bit to get negative 3x squared y cubed minus, two of these will cancel with one of those, so minus 3x to the 6th divided by y, and in the denominator, y to the 6th. Now, be careful, we can't leave complex fractions, so we need to multiply through by the common denominator of y. When we do that, we will end up with negative 3x squared y to the 4th minus 3x to the 6th, because our y's will cancel in that second term, and in the denominator of y to the 7th. At this point, something really interesting sometimes happens. And you're going to see here when I factor it that I can pull out a negative 3x squared, which leaves me with a y squared plus an y to the 4th plus an x to the 4th, all divided by y to the 7th. Now, at first glance, that might not mean anything because nothing cancels with our negative 3x squared and our y to the 7th. But if you look back up here at the top, what did x to the 4th plus y to the 4th equal? 16, which means I can replace this with a 16 to leave my second derivative as negative 48x squared over y to the 7th. Make sure you take good notes on that one. If you need to rewind to write it down or listen to it again, please do. Remember, you can always pause or rewind as needed, and we will see you tomorrow.